All right, so let's look at how to solve two different types of projectile motion problems. So the first one is a horizontally launched projectile, meaning that if I throw something like in this case off of a cliff straight, it has an initial velocity in the x direction, right, this way. But in the y dimension, there's no initial velocity, right? So there's an initial x, no initial y, right? So what other variables do we have? Well, if this thing travels this way, that's the x displacement, right? And then the height of the thing that you're throwing it off of, right, is your y displacement. So horizontally launched problems are really easy because there's no y component. Everything in the initial case is all x velocity. So we have two different dimensions, so we have two different equations, right? So in the x dimension, the only equation that applies this way, there's no acceleration. The only equation in the x dimension is velocity. My x velocity is my x displacement divided by my time interval. Okay, and in the y dimension now I have acceleration, right? But my equation is going to look like this. So delta y equals v naught in the y times time minus g delta t squared over 2, 1/2 gt squared, right? But in this case, when I shoot this thing this way and I don't give it any initial y velocity, this initial y velocity is 0, right? So that makes this whole thing go away. So basically my y equation is y equals 1/2 gt squared, right? So I can have delta y equals 1/2 gt squared. And then we talked about this in class. If I rearrange this equation, I can make it really useful and say the time is 2 times the height over g, right? So these are my two y equations, and here's my x equation. Okay, so let's do an example. So let's say I shoot something off a 1 meter high table. So I'm going to make this 1 meter, and it has an initial velocity of 0.75 meters per second. And I want to figure out how far away this thing lands, right? So first, obviously, draw a picture. Pictures will make solving things so much easier, okay? So now let's go solve this. So always, always, always projectile problems, the first thing you need to do is find the time interval. Have to do that first, okay? So let's look at what we have and see how we can figure out time, okay? So let's jump to this one. That would be easy, right? Time is the square root of 2 times the height divided by g. I know the height, I know g, right? So I can use this equation. So my time is going to be 2 times the height, that's 1, over g is 9.8, square root of that whole thing. So that gives me a time of 0.45 seconds. All right, got my time. Now I'm basically done, right? So I'm trying to figure out the distance, right? I know time now. So if I look at this equation, velocity is my x displacement over my time, right? The distance. So if I want to solve for distance, I can just rearrange that equation, right? So now I can say if velocity in the x direction is delta x over delta t, that means that delta x is going to be velocity in the x times my time, right? And my x velocity is 0.75, and my time I just said was 0.45. So that means that delta x is going to be 1.66 meters. So this thing, roll it off the edge of the table, this delta x is 1.66 meters. Horizontal problems, really straightforward, right? There's no y velocity. As long as you remember, first find the time, here's your two equations, right? And the x equation, there's no acceleration. The other type of projectile problem is called an angled launch, right? And that's because you're launching it at an angle, right? So I have some initial velocity that I'm kicking this ball at or something, right? And it's at an angle to the horizontal, right? So I've still got a delta x, right? My horizontal displacement. Sometimes you'll see this called the range. And there's still a height, right? I can solve for the height at anywhere on here, right? Because all these points, this ball is going up and it's coming down, and I can solve for the height somewhere, right? But the thing is, I have this initial velocity here. And if you see a vector that's in 2 dimensions, I have to break this into its components, right? So this initial velocity that looks like this at some angle theta, I need to break this. Before I can go solve this problem, I have to turn this velocity into an initial velocity in the x direction and an initial velocity in the y direction, right? And I can do that by using sine and cosine, right? So this one would be v naught cosine theta, and this one would be v naught sine theta, right? Because this one is the adjacent side, cosine. This one's the opposite side, so it's sine. Okay, so in an angled launch, I still have an x and a y equation, right? And so in the x direction, there's still no acceleration, right? Gravity still only points in the y direction. So in the x direction, my equation is still, my velocity in the x direction is delta x over delta t, right? Where this x velocity is this number, right? And that number never changes because there's no acceleration this way. That's got a constant velocity the entire time. Okay, so the y is where we have to use that other equation, right? So same equation we talked about with the horizontal launch, right? So it's delta y, my y displacement, equals my initial y velocity times the time minus 1/2 g delta t squared, right? So g delta t squared over 2. So in this case, I have a y velocity, right? So I can't just go get rid of this like I did last time. I have an initial y velocity. And notice this negative sign here. I have the negative because now this thing, when the ball goes up in the y direction, it's going to turn back down and come down. There's a change in direction, so I need to call g negative 9.8. Putting this negative sign here, that takes care of that. Okay, that's why this is negative and the original equation is positive. But still, two equations, right? As long as you keep straight what's in the x, what's in the y, you can pick which equation you're going to use to solve what you need. So let's do an example real quick. I'm going to say I kick a football at 20 meters per second at a 36.8 degree angle. And over here, there's this goalpost, right? So goalpost like this. And this goalpost is 3.05 meters off the ground, right? So when I kick this thing, 20 meters per second, 36.8 degree angles, this is, I'm going to say it's 34 meters away. I want to know, if I kick this hard at this angle, am I going to make the field goal, right? So same way we approached the last one, right? Except now, before we find the time, right? So step one is always find the time. Step one is now take this vector and break it into its components. I can't do anything until I break this into components, right? And so if this is 20 and that's 36.8, right? You can check this, but your y velocity, if you do this, it's going to be 11.98 meters per second. And my x velocity, 20 times the cosine of 36.8, that's going to be 16.01 meters per second, all right? So that's my y, that's my x. So same thing. First thing we got to do is find the time. Got to do that first. So let's look at what we know. Okay. Finding time on here would be solving a quadratic, right? I don't want to do that. So let's see if I can solve my x equation for it. Okay. So x velocity. Do I have that? Yes, I do. I broke it down, right? So I've got x velocity. Okay. Do I know delta x? Yes, I know it's 34 meters away, right? So good, I don't have to solve a quadratic. So I can say velocity in the x direction is delta x over delta t, right? So if I want to solve for delta t, doing the algebra, that would give me delta x over my x velocity, right? And so if I do that, if I do my delta x 34 over 16.01, I get 2.12 seconds. That's my time. Now I'm done, right? Because I've got time, I can plug time into here, and I can solve for the height, right? So what I'm trying to find is the height at the time that it took me to get to the goalpost, right? So it took 2.12 seconds to get to the goalpost. That ball went up, and then it came down, and so my delta y, if it's greater than 3.05, I made the field goal. So let's try it, right? So I'm going to say delta y equals initial velocity in the y, that's 11.98, times my time was 2.12, minus 1/2 times 9.8, right? G, t squared over 2. So times the time squared, that's 2.12 squared. And when you do this, if I take this number and subtract the 2, I get a delta t of 3.29 meters. So that means that at this point over here, my ball is 3.29 meters in the air. The ball's 3.29 meters. The goalpost is 3.05 meters. I made the goal. I win the football game. Hooray. So solving projectile problems, really straightforward as long as you keep separate stuff that's in the x dimension, stuff that's in the y dimension, right? I can only use my x velocity with my x equation because there's no acceleration in the x. I can only use my y velocity with my y equation because there is acceleration in the y. As long as you keep those things separate and you draw pictures so that you can see everything, solving projectile problems really should be pretty straightforward.